Okay. So today we will discuss about we'll correlate the circular motion of a point with the simple harmonic motion. Okay. So you can see here. Let us say this is circle and this is the point. Okay. This point is rotating at a angular velocity omega. Okay. So now I was telling that if linear velocity is v, the corresponding angular velocity is omega. Okay. So omega is angular velocity, okay, which is nothing but theta by t. Theta by t, angular velocity. Linear velocity is what? Linear velocity is x by t. Okay, if linear velocity is x by t, angular velocity is theta by t. Means the linear distance travel per unit time, that is the angular distance travel per unit time. Okay, so uh, and okay, so that's omega, and now there can be when we take the projection of this point when it is rotating, we can take the projection of this point on the x-axis. Okay, when we take the projection, the equation of this point, if we take the projection of each point on this axis, let's say this point projection is here, this point projection is here, this point projection is here. So here this point projection is here only. Okay, right? So this point projection is here, this point projection is here, this point projection is here. So this for let us say this is 0, then this is pi by 2, then this is pi, then this is 3 pi by 2, then again it is 2 pi. So from 0 to pi, this point will move from this to this. Okay, for 0 to pi. For pi to 2 pi, again this point will move from this to this. Okay. So this projection is it is same as a to and fro motion, like that what we have discussed. So this equation can be written in terms of x is equal to a cos omega t plus phi. Plus phi. Okay. So you imagine this phi is equal to 0. Okay. If the phi is equal to 0, it will start from here. Okay. If phi is some angle, it will start from here. If phi is some angle, the motion will start from here. If phi is equal to 0, the motion will start from here. So this equation is nothing but projection of this point. Projection of this point when it is rotating in circular motion on the x-axis. This is the equation. And now, if you project this point on the y-axis, it will be projected here, it will be projected here, like this it will go on. Okay? So it will go on like this, then it will come back like this, then it will come back like this. So that is also like that equation will become x is equal to a sin omega t plus phi. Okay, so this is this. So this is how the circular motion can be related to the simple harmonic motion. So these are the equations of simple harmonic motion. Okay. So now we'll do velocity and acceleration in simple harmonic motion. So in any simple harmonic motion, we will study how do we derive what is the velocity and what is the acceleration. So velocity and acceleration in SHL. Okay. So this is the equation for displacement. X is always displacement. Okay. Then what will be the velocity? Velocity is nothing but d by dt. X is again a function. Okay. So you know velocity is nothing but rate of change of displacement. That you know. Okay. So velocity is displacement by time. Okay. So when it is infinitesimal, you write it as a derivative. The velocity is dx by dt. Okay, so here d by dt xt xt. Okay, so this is x as a function of t. And here it is x as a function of t. Okay, so you can derive it is with respect to t. So here it is become a cos omega t plus r. Okay, so this this will become this derivative will become because this will become uh, omega. This term omega will go outside, right? You know, d by dt cos omega t is nothing but derivative of cos omega t. Nothing so it will be minus. It will be minus. So it will be cos minus sin omega t. You know that derivative of cos omega is sin. Okay. Minus sin. So derivative of cos theta is minus sin theta. And this constant term also will go outside. Yes. So derivative of cos omega t is minus sin omega t. Minus omega sin omega t. Yes. So in this case, it will become omega a. A will anyway remain the same. Yes. Right? Sin omega t plus right? Yes. Sin omega t plus phi. This is the derivative. Okay. This is the derivative of displacement. Velocity is equal to omega a sin omega t plus phi. This is the equation for velocity. So what will happen? What is the maximum velocity? Maximum velocity that is the V max when sin omega t plus phi is equal to 1, right? Sin omega t is, sorry, this is, we don't write, we should write it like this. Omega t plus phi, sin omega t. Omega t plus phi will be in the bracket, not sin omega. Yeah. Okay. So V max, you know, sin maximum value is equal to 1. Yes. So V max is equal to minus omega into the amplitude. Right? Yes. So that's the expression for maximum velocity. Okay.
Oh, maximum acceleration.
Yeah. So that is the expression for maximum velocity. Similarly, you know acceleration. Okay. So if this is velocity, similarly there is acceleration. Okay. So A is nothing but d by dt, dv by dt. So velocity is rate of change of displacement. Velocity is rate of change of displacement. Acceleration is rate of change of velocity. Okay. So again, this term like d by dt into this term will have right here. Okay. Minus omega a sin omega t plus phi. Okay. Minus omega a sin omega t plus phi. Okay. So again, this omega will go outside, and this sin will become cos now.
Yes.
Sine when it becomes cos, it is not. It will not become negative.
Yeah.
Okay. So d by d theta sin theta is equal to cos theta. That you know.
Yeah.
D by d theta cos theta
Is minus
is
sin.
minus sin theta. Right.
Yes.
So here the acceleration d by dt omega is sin omega t. This omega will again go outside, so it will become omega square a. Then cos omega t plus pi. Clear? That omega will go outside. So what will be the maximum acceleration? So maximum acceleration is equal to minus omega square a. So that is the expression for my maximum acceleration, and maximum velocity is minus omega a. Yes. So these are some of the important things you should always remember. Okay. Maximum velocity. The velocity is dx by dt. Acceleration is equal to dv by dt. Velocity max is equal to minus omega a. Acceleration max is equal to minus omega square a. This is the summary of picture. Okay. We can take a picture. We will solve some numerical. Okay. So we have correlated circular motion, the projection of a point on the x-axis, y-axis. It can be an equation of simple harmonic motion, and we have derived what is velocity, what is acceleration in simple harmonic motion. Okay. So let us solve a numerical. Okay. A body oscillates with SHM according to the equation in SI unit. Okay. So the equation is, let us say, x. See, this numerical is very important. You can get a numerical. You can formulate n number of numerical using this equation. Okay. So the equation of motion is x is equal to 5 cos 5 cos 5 cos 2 pi t plus pi by 4. Okay. This is the equation. Okay. At t is equal to at t is equal to 1.5 second, calculate the displacement, the speed and acceleration of the body. Okay. So
Yes.
Okay.
Yes.
So you will calculate the displacement. You will at t equal to 1.5. You will calculate displacement. You will calculate velocity, and you will calculate the acceleration of the body. So this equation of displacement is already given. Okay. So phi cos, then it is 2 pi into T is 1.5, right?
3.
1.5, okay, plus 5 by 4.
Yes.
Okay. So 1.5 into 2 is 3 pi, okay. So it becomes I cos
3 pi plus 5.
3 pi plus 5 by 4. So 3 pi plus 5 by 4. Okay.
Yes.
You know, this is your this is this is your quadrant. Let us say this is your quadrant. So this is 0.
Falls in first
This is
quadrant.
pi by 2. This is pi. This is pi. This is 3 pi by 2. Then this is 2 pi. Okay. So let us say this is 2 pi. Pi first. Okay. 2 pi plus pi plus pi by 4.
Yeah.
So this is one
Third quadrant.
So this is falling in the third quadrant. Okay. So this is falling in the third quadrant. So in this quadrant. Okay.
Yes.
So so this cosine value. So if you remember the cosine value in the second quadrant is negative.
In third quadrant, positive.
Third quadrant it is positive. Okay, so if in the third quadrant it is positive, that means it will be 5 5 into cos 5 by 4. Okay, so it is cos 3 pi plus 4. Okay, so so you forget about this 2 pi. Okay, just you consider it as cos pi plus pi by 4. Right, because
It will be
2
the
pi
same
means it
thing.
is just
Yeah.
repeating. So forget about 2 pi.
There also will be pi plus 5 by 4 means third quadrant.
Third quadrant. So 5 plus 5 by 4. So you know cos 180 plus theta. What is the value? 180 plus theta. It is positive value. Is it
Positive
cos
value.
theta?
Yeah.
Cos theta.
So this 5 cos pi by 4.
So it will become I cos pi by 4. Okay. So pi by 4, cos pi by 4 is nothing but 1 by root 2. 1 by root 2. So pi by root 2. So root 2 you know is 1.412. Okay. So always remember this value. Root 2 is 1.414. So you don't have to spend too much of time. Root 2 is 1.414. So this is 5 divided by 1.414. Okay, so no, I think it is minus cos theta. I did not know. See, this is minus. This is minus.
This is third quadrant, second quadrant and third quadrant negative.
That's what. This is minus cos theta. Okay, second and third quadrant are negative.
Negative.
So this is minus cos theta. So this will become minus. Sorry, this is fine. So it is minus cos theta. So here it will become minus. Here it will become minus. Here it will become minus. So 5 by 1.414, which is nothing but minus 3.535 meter. This is meter. Because unit of displacement will be meter. Unit of velocity will be meter per second. Unit of acceleration will be meter per second square. So we found value of velocity is displacement is minus 3.535 meter. Clear?
Yes.
You can do it now.
Yes, yes.
So this is the value for displacement, which is minus 3.535 meter. Then the next question is
Velocity.
what is the velocity? So maximum velocity is you will
Displacement by time.
hmm, uh, it is nothing but your it's uh, it's nothing but your um, we have derived it to be velocity to be uh, omega a omega, so derivative of this. So this here it is omega is 2 pi. This is the value of omega. Correct. So it will become omega a, okay, and the derivative of cos is sine, okay, minus sine, right?
Yeah.
Derivative cos is minus sine. So it will become omega a minus sine, then 2 pi into t is 1.5 second, okay, right? Plus pi by 4, okay. So this is your equation. Okay. Omega a, and omega in this case is 2 pi, right? Right?
Maximum velocity.
Are they
That is maximum velocity point.
calculate the displacement speed at some, no, nothing maximum. At 1.5 second, what is the value of velocity they are asking? Nothing maximum here. Okay. So your omega is 2 pi here. Okay. What is omega? Omega is the like angle per unit time. Okay. So here angle covered per unit time is 2 pi. Okay. So this is 2 pi into a into sine cos omega t has become sine omega t plus pi by 4. Okay. So this will become minus 2 pi. Then your a is nothing but your 5, right? 5, no? A is 5. So from this equation you know your a is 5, your omega is 2 pi. Okay. See, x theta, b omega, okay, acceleration alpha. So in linear, it is x, b, and a. In angular, it is theta, omega, and alpha. Okay. So omega is your angular velocity. So unit of velocity is meter per second. Okay. Whereas uh, unit of angular velocity is radian per second. Okay, radian per second, because unit of uh, v is equal to x by t. So x unit is meter per second. Okay, but omega is nothing but theta by t. So what is the unit of theta? Radian or degree. So we will write it as radian per second. Okay. So that is omega. Okay. So in this case, this omega is nothing but 2 pi radian or whatever, 2 pi, right?
Yes.
2 pi radian per second. So you now for max velocity, what is the velocity at a time of 1.5? So you replace a by 5, then write sine, then this becomes 3 pi plus pi by 4. Right? So this becomes, let us say, minus 10 pi, then it will be 2 pi, you forget that 2 pi, this is pi plus pi by 4, right? Okay, so minus 10 pi into sine 180 plus theta, what is the value?
That is plus sine.
Cos theta. Will become cos pi by 4. Okay, so it will become minus 10 pi into cos pi by 4 is nothing but 1 by root 2. So 10 pi divided by 1 by root 2. Huh? Or yeah, 1 by root 2. So Yeah, so it becomes 10 pi divided by 1 by root 2. So 1 by root 2 is nothing but 0.707. So minus 10 pi into 0.707 in meter per second. So that comes out to be 10 into 10 pi. 10 pi is nothing but 3.414. So velocity is equal to
minus
your
10.
minus 10 into 3.414 into 0.707. So how much it comes out to be? 2.2. So 10 into 3 is something around 30. So it comes out to some 22 meter per second. Here.
Yes.
Any doubt here? What is there to be getting confused here? These trigonometric values are very, very important. I cannot remember what is cos A 180 plus theta, what is sin 180 plus theta. You have to by heart this. One can, when one is solving a numerical like this, one cannot start deriving what is cos 180 plus theta. You have to remember. Okay. So this is the equation. This is the answer for velocity. Similarly, the acceleration. Okay. Similarly, the acceleration. Let us say your a value. Okay. So the equation will become like uh, the equation for velocity we have written as this. Okay. So uh, here you have written this as omega. Okay. So acceleration we have derived to be omega square. Okay. So that is the expression for acceleration is minus omega square a cos omega t plus phi minus omega square a cos omega t plus phi. Okay. So here you know omega is 2 pi, your phi is pi by 4. So you know all this. Omega is 2 pi, phi is pi by 4, and then t is 1.5. So uh, so you replace this omega value as 2 pi, omega value as 2 pi here, t as 1.5. After replacing all this, so this is the homework for you. You have to do it and show it to me. Okay. So after replacing omega as 2 pi, omega as 2 pi, time as 1.5, phi as pi by 4, you will get the acceleration to be 140 meter per second square. 140 meter per second square. You will show me how you got 140 meter per second square. Okay. So this is a very, very important equation. There is 100% guarantee that you will get a numerical on this for sure. Okay. So you should remember the expression for velocity, the acceleration, and in simple harmonic motion. Okay. So next to that, we'll do some numerical. We'll get into the spring mass system. Okay. Okay. Next session we'll do the spring mass system. Okay. You can take a picture of this. Okay. Thank you.